So today we're going to talk about inverse functions. To begin with, we have to understand this word relation. Relation is just basically saying that you have pairs of x and y values. So maybe it's 1 and 2 and 3 and 4 and 2 and 5 and 1 and 7. Okay? And so there's really no rules to it other than that x and y are related and put together in pairs. So what happens is, I guess what's missing here and what I'm kind of frustrated with is that I don't have this word function written down. Because if you remember in the past, what we've talked about with functions is it's just like a relation, but we don't have this problem right here where when you have a 1 that goes with the 2, you don't have a 1 paired with something else later on. So this would not be a function because of that added 1. So if I cross that one off and I only kept these 3, then I would have a function. And so then what we move into is something called an inverse function. And basically it's pretty simple actually, is all you're doing is you're switching your x and y values. So here we have this function right here. We have -2, 4, -1, 2, 0, 0, 1, -2, and 2, -4. There's no repeats of x values, so I don't have to worry about it not being a function. And then we go into the inverse, and the inverse, what it's going to do is it's going to switch your x and y values. But before I get to that, you'll notice here the notation here is just a little bit off. I want to change that a little bit. It's just some of the typing didn't transfer. So what that looks like is you have your f of x business like you normally do for a function. But then in between the f and the parentheses, we put this exponent of -1. Now that's not a typical exponent that moves things down to the bottom. When it's put in function notation like this, what it is it's the inverse, and it's saying we're switching x and y. And so now what I'll do is I'll write, instead of the -2, 4 that we have here, we're going to write that as 4, -2. And then the next one's going to be 2, -1. And the next one's going to look exactly the same because when we switch the zeros we still have 0, 0. And then we'll have -2, 1. And we will have -4, 2. And there's the inverse. Now we want to look at the graph and see what happens when the graph when you have this. So what I'll do is I'll start by graphing the top one, and I'll graph those in black. So the original was -2, 4. I don't have my pen, so it's kind of hard for me to do these dots. And then -1, 2, 0, 0, 1, -2, and 2, -4. Okay, now in green, I'm going to do the inverse. We had 4, -2, 2, -1, 0, 0, -2, 1, and -4, 2. And so you'll see that it looks kind of like an X crossed a little bit there. And what I want to point out, what's really cool about inverse functions is they're reflective on the y equals x line. So basically, if you imagine those black dots being attached, these black dots being attached to this line right here, and imagine I rotated the lines, so I'm grabbing the line on the ends and rotating it, then it's going to be flipped over to these ones right here. It's kind of hard to imagine. Maybe you can, maybe you couldn't. So now, what if it comes to you in equation form? See, before it's really easy when it comes to you in those x, y forms, but what if it comes to you in equation form? It's still going to be the same steps. Okay, what we're going to do is step 1 is we're going to switch x and y. Sorry, I don't have my pen. I'm not sure where it went. Okay, so that's what I'll do. I'll switch x and y. So now I'm going to put x where y was, and now y where x was. And then step 2 is we solve for y. So I'll add 4 to both sides. X plus 4 equals 2y. And then we divide by 2 on both sides. And so now my inverse is y equals x plus 4 over 2. Do not cancel the 2 and the 4 because x doesn't have a 2 on it. We can't cancel them. All right, and this would be my inverse. Now watch what's cool about that. So Normally if I'm in class, I'll say, someone pick a number for me, so I'll just go ahead. I'm just picking a number that's small enough to work with, but there's nothing special about the number, so we'll just pick 3. And what I'm going to do is I'm going to plug in 3 for x. So if I do that, I get y equals 2 times 3 minus 4. I get 6 minus 4, that equals 2. Now here's what's cool about that. If I take that 2 and I plug it in for my inverse, I should get back what I started with, which was 3. So let's try that out. I plug in 2 plus 4 divided by 2. 2 plus 4 is 6. 6 divided by 2 is 3. And so that got my inverse brought me back to the 3. So let's try this again. This is somewhere where you can hit pause and try it yourself. So we will go with finding the inverse. You switch x and y. So now we have x equals negative 3y plus 6. And then we solve for y, so we'll subtract 6 from both sides. X minus 6 equals negative 3y. Divide by negative 3. And so your inverse is y equals x minus 6 over negative 3. And let's just do one last example. Alright, so now it's just a matter of you being able to do your math. Switch x and y. X equals 1/3 y minus 1. Add 1 to both sides. And then now to get rid of the 1/3, I'm going to multiply by the reciprocal. So I'm multiplying by 3. So then 3x plus 3 equals y is my inverse.